This evening, your reviewer will be lubricated by Pioneer Harvest Stout from Farmery Brewing in Neepawa, Manitoba. So today, I am taking a closer look at this Hantek LCR meter that Banggood sent me a week or so ago. I've spent a little bit of time with it and done a fair bit of research. Enough to know that I'm just going to scratch the surface tonight on LCR meters, what they can do and what not, but I think I've got enough to be able to put this thing through its paces, at least at a beginner level, and let you know what's going on here. So, in the fairly nice little semi-rigid case, there is the meter itself. There is a USB-C lead, which is used both for charging the thing and also for getting data out of it if you are using a Windows computer. So if we plug that in to a USB charger, you see the light, the LED behind the power button lights up. That tells us that it's charging. Give that a quick press, and it wakes up. And you notice that the internal battery is charging, telling us two things. One, that the charging circuit works, and two, that there is an internal battery and it's rechargeable. If I pull the USB out, showing that I've got a full battery, so I'm just going to leave that out for the remainder of what we're doing today. So we'll just take a quick look-see around the case, I guess. On the front we have, typical meter stuff, screen, bunch of soft little buttons. Down at the bottom we have the connections for the probes that come with it, and a second set of connections where you can just shove the leads of a component into there. Yeah, there's a little resistor. You can just jam him into the spring terminals and it's held there. And that would be probably a better option for capacitive and inductive pieces, so that you don't have any extra capacitance or inductance thrown in by these leads. However, just above that, we see a button labeled Calibrate, so we can zero out the leads to reduce their impact on what's going on the readings. Up top here is an interesting little recess in the casement, and it turns out that is because Hantek uses the same plastic case molding for a bunch of different products, and some of them have connections up top. Who knew? Over on this side we have the little flappy cover, and again that is used on a bunch of different cases. We've got power and USB, SD card, and another USB. However, the only one that's actually populated is this power and USB combination here. This USB doesn't exist, and this SD card slot doesn't exist. Yeah, I mean, there's a place in the case for it, but there's no electronics down there. That confused me when I first opened this thing up. Round back, we have a little Kensington type security little lockdown thing. That's okay. I guess if you're leaving it in the lab and you don't want somebody borrowing it, sure. And then underneath the little kickstand, it's got some little grippy bits, so you can hold it onto something if you put it over top of I don't know, a pipe or board or something. It'll sort of hold in place. Then we have two screws down here of the Torx variety. Torx T10 specifically. Okay, there is the battery cover. Oh, this little edge engages into a slot there. That's fairly positive. We have a pair of 18650 lithium-ion cells in here. They call themselves 2600 milliamp hour. Okay, and wow, they're from earlier this year. That's nice to see. And down in the battery compartment, the positive and negative are labeled, clearly labeled, so that's good. And the cells are labeled as well. Nice little bit of heat shrink up there, just so you can't accidentally splash against there. That's good. To get at the rest of these screws, there's 4 more screws on the corners here. I had to take this little, it's not rubber, but rubbery, flexible piece off the outside, and it was really held in. It's It's held into little slots all the way around, all four edges, front and back, that go into, can you see those pieces in there? It was a real struggle to get it out, but I've got it, so now I can carry on and see what the secrets are inside here. Okay, there's the 4 self-tapping screws into the plastic. And now, hopefully it comes apart. Yeah. What's holding it together? Oh, a warranty void sticker. How cute. Take this little cover off the USB thing there. And you can see the USB connector buried down in there, and we can see that there aren't any other USB or SD connectors or anything around there. But there is this ribbon cable that's really folded and creased up in there. Not a super big fan of it. Although on the Flatflex connector, they do have some cloth tape reinforcing it, so that's nice. The same thing with this one over here. There is the keypad beeper. So some protection diodes down here at the inputs. There is the input jacks and the other input jacks up there. These input jacks are not in parallel with each other. Not completely anyway. It's set up to be able to do a 4-wire measurement. Even though you can measure from either pair independently of the other, it can also do that 4-wire measurement thing. Those are again self-tappers. That board lifts off, reviewing another board underneath. Yeah, I'm not going to go too far into there. The other board underneath there will have the display and the keypad on it and stuff like that. All the measurements and whatnot are being done up on this board. Got a bunch of smaller components, amplifiers and whatnot, likely. Again, I'm not going to go down too deep into there. Maybe analog to digital stuff. And then there is the processor up there. I don't really want to mess with those Flatflex connectors. They can be fragile and finicky if you're not super careful. So I think I'm going to put this guy back together again. It looks like it's fairly robust, fairly solidly put together inside here. The battery holders are nice and solid and firmly soldered down. So a little bit of flux residue left down here from when they were manually soldering on the jacks. But other than that, and this here, kind of foldiness, it looks like a pretty solid little device. That's worth drinking too. It still works. So I'll connect the 2 short little leads that come with it back on there, and I'll just put it into capacitance mode, and you notice that with nothing connected, there is a few picofarads showing. So there is a calibration mode on this little button here, and I'm going to run through that. You can just push and hold for a second. It gives you some quick instructions on screen. Now I've got the probes shorted together, so it is saying insert the shorting piece. Oh yeah, one other thing that came with in the kit is this little metal shorting piece that you can put in there. If you're using those spring terminals to insert leads in, then you can short it there for calibration. But since I'm using the leads and I want to actually calibrate out the leads, I am going to leave them in and then press the rel button like it said. As you can see, it's going to run through a bunch of different frequencies and impedance tests or resistance tests. And it's going to take a little while to do this, so I'm just going to let it do it. I'll come back in a second. Okay, so time has passed and it's finished its short circuit calibration. And it says just push the button again to exit. So now we'll test it open circuit, with the leads just hanging out open circuit. So we'll go back into the calibration mode again. And you see that it says no plug-in is the open circuit calibration, so that's what we will do. And that's running through. And again, it's going to take a bit of time, so okay, that is complete. So exit that, and we should be back in in open space. And there we go. With nothing connected to the leads, we're showing essentially 0 picofarads and also 0 inductance. So I guess I should measure some things with this just to show how that's done. Now then, this being an inductance and capacitance meter primarily, it can also do straight up resistance, but we have lots of tools that can do those. Every multimeter that I have can do that. And also capacitance, about half of the meters, the slightly higher end ones, can also do capacitance, though they can't do the other components of capacitance, like ESR specifically, equivalent series resistance, which is also useful to tell if a capacitor is at end of life or failed completely. You'll see the that resistance start running up. Now, the big thing that separates an LCR meter from a standard ohm meter or multimeter is that it is doing its measurements in AC mode. When you're doing a resistance measurement on a typical multimeter, it's going to be a DC measurement. So when you're doing AC measurements, there's a bunch of other things that come into play, and that's, for instance, on the meter itself, you can select what frequency you want that measurement to be taken at. In this case, anywhere from 40 kilohertz at the highest down to 100 hertz at the lowest. And that goes both for capacitance and inductance, because both of those are inherently an AC device. For resistance, it doesn't really matter. Well, almost. If you're measuring just standard resistors like this one here, it doesn't matter what frequency you measure them at. There's at 40 kilohertz. There's at 100 hertz, 120 hertz. That doesn't really impact the resistance measurement. But since we are doing AC measurements, we have another component that we can measure even with a simple resistor, and that is X, which is reactive impedance. That is an AC resistance, sort of. I'm not going to go too deep into these things. I'm going to link to a whole bunch of Wikipedia pages if you want to dive deep into the math. But basically, that is the resistance to AC current at the frequency that we're measuring right now. So if we step that up to 40 kilohertz, it's going to change because there is an inductive and capacitive component. And actually, every component, be it a resistor, an inductor, a capacitor, has bits of the other three components as part of them, just inherently, accidentally. There is no ideal perfect resistor or capacitor or inductor. They've all got bits and pieces of the other guys in them. I didn't really want to go down this theory rabbit hole, but I think I'm going to. So, remember I mentioned that every capacitor, inductor, resistor is all three in one. So, the capacitor, one of these guys, also has an inductive component and a resistive component. But that component could also be in series with it. And there is some component in all of those different modes, and the same goes for these guys. There's a capacitor and a resistor that could be, or that, some component of each of those in series and in parallel. Now, how much of that has any significance on your measurement is going to depend on the value of your component and a little bit the frequencies that you're messing with. So again, I'm not to scare anybody off, because the meter does help you an awful lot, and but it does take a little bit of understanding of what you expect to get as a measurement to interpret it correctly and not get thrown off by accidentally measuring one of the other guys. So just take a quick look in the manual, and I'll put a link to that down below if you're interested. It has some accuracy charts in it showing the different accuracy levels in different capacitance and inductance ranges at the different frequencies. So for instance, if you're measuring at, in the hundreds of hertz, and you're measuring something that you expect to be in the 4 to 20 millifarad range, then you're going to be only 8% accurate. But at those same frequencies in the low hundreds of microfarads to tens of microfarads, you're going to be 0.4 to 0.6% accurate, which is probably close enough for most of us in the audience here. And then again, if you're measuring these ranges, you'll want to use 1 or 4 kilohertz to get your accuracy. And then of course there is the same set of charts for inductors. Okay, so back from theory world. I hope I didn't lose too many people. Let's actually test a few components here. I have my kit of brand new capacitors. Some of them are higher quality than others. This is a 100 microfarad electrolytic capacitor. And like I said, it's a new one, and this particular one's a relatively high quality one. It's not one of the cheap Chinesium ones. And according to that chart, the frequency should be, relatively low in the hundreds. So we will do that. And what have we got? 90.5 microfarads with an ESR equivalent series resistance of 1.49. And ESR is another thing that, oh boy. Again, Wikipedia links down below. Basically, the lower the better. And what's good and what's bad is going to depend on the capacitance range that you're in. I'm going to print out some of these charts that I've found on the various places that I'm linking below and just keep them in the case with this thing, because I'm old and my memory is not what it should be. And now inductors. And inductors have their own secondary characteristic that is a little bit confusing and a little bit mathy, and I will link to information about it. That is called Q, which is known as the quality of the inductor. Now, I don't have a lot of inductors of known inductance around here. I do have this package of, I can't read the writings, either 10 or 100. But let's step down into, say 400 hertz. So we have a 110 microhenry. Let's try it right down to 100 hertz. 112, yeah. So if you're close to the range, if you don't have a chart handy, if you're close to the range, anywhere from 120 up to 1K is giving us right in around the 100 microhenry. So that's a pretty good indication. And you notice as we step up in frequency, the Q increases as well. There's at 4 kilohertz. There's at 10 kilohertz. Now then, I'm not sure if I want to go too deep into explaining Q, other than that it is a mathematical relationship between inductive reactance, aka resistance at frequency, the actual inductance, and what? There's one other thing. Frequency. Anyway, follow the link down below. So I am also going to link you to Hantek's page on this, as well as Banggood's page. The Hantek page has downloads of the firmware, and it looks like the one that I've got is only a month older than the latest one that they've got available. The manual and the software for putting on your Windows PC, if you have, or Windows laptop or whatever, that's the only platform it works on. And here is the meter on Banggood. They're the ones that sent me this one for review, so I will link to their sale page on it. Currently, it says it's selling on sale for $169.99 US. They've already linked to my unboxing. Oh, cool. Anyway, yeah, there's my unboxing video on it if you want to see my very first impressions on it. Anyway, here is the specs and parameters and everything. This is all in the manual as well. And then they also have links to the manual, the firmware, and the software, so you can download it from there also. That's quite the meter. As I said when I did the unboxing a couple of weeks ago, I have never played with one of these before. I've never had access to one of these before. But it is showing me a lot of more information about components than I ever had access to. As I mentioned, a few of my higher end multimeters can do capacitance. None of them can do inductance. This cheap little component tester can do inductance, but in a very narrow range of values, and even at that, it doesn't compare super well to this guy. And I am definitely going to trust this guy more. But if you're an absolute beginner and you don't need weird values or values at the edge of the ranges, that's not a bad starting point, and Banggood has those too. Sorry, have to show a little bit. But yeah, I do like this thing, and I'm pretty confident that I'm going to get quite a bit of use out of it, especially for things like checking the ESR on capacitors that are coming out of things if I'm suspicious that they're in trouble. I didn't wind this inductor for this demonstration. I was doing that for something else. I was tinkering with switch mode power supplies and just seeing what I could do with them. But there's lots of inductors to be salvaged if you out of switch mode power supplies, and it's always useful to know the measurements of them and what you've got so that you can actually use them in a different circuit, right? Well, I hope that was somewhat informative, not too overwhelming, not too chaotic. Questions and comments down below. There will be a whole ton of links down in the description. Try not to get overwhelmed by them, but if that's a rabbit hole you want to go down, absolutely. And as I mentioned, there will be a link to Banggood to this. It will be an affiliate link, but I think they've given me a discount code, so that's there too. Anyway, thank you for watching. I will talk to you later.